So this is another style of proof tutorial where I'm not letting you loose on a full proof yet. In a full proof, I would just say, hey, look at this thing up top. Show me it's true. And then you do all the steps. You come up with everything and justify everything that you're doing. We're not there yet. What I want you to do in this style of problem is we're going to take a look at the left side. See, I'm putting that in red. We're going to take a look at the left side of this proof. You can work on whichever side you want. But in this one, I'm choosing to work on the left side, and I want you to justify every one of these steps that's happening as we go through this proof. Okay, so I'm doing the proof for you, and you're telling me how it is that what I just did was okay. Okay, what was the rationale for it? So let's do the very first example. And remember, what I'm saying for each of these answer boxes is how is each step justified from the previous step? Okay, so as we're looking at that first answer box right here, what I want to know there is how did I go from what I started with in red to this first line in black? How did I go from secant minus 1 and secant plus 1 in the denominators to secant squared minus 1? And as you look over these answers, you can do this by process of elimination. I think it would be better to not do process by elimination and instead just figure out how it worked. What was the rationale? And approach it that way. So when I have one here, I'm just going to write this out. Secant theta minus 1 plus this other fraction was secant theta plus 1. If it was your job to add these together, you might say, oh, well, let's just use common denominators, right? So you would use a crazy one. On this one, you'd need a secant theta plus 1 over secant theta plus 1. And on this one over here, you would need secant. No, I messed that up. Hold on. Get that plus sign out of there. So the one on the right needs secant theta minus 1. The one on the left needs secant theta plus 1. All right? And as you multiply that out, look at these denominators. This is a difference of squares right there. So it's going to become secant squared minus 1. That's what we have right here. So the answer that I would choose for this guy is rewriting with common denominators. All right? Now, let's go through some of the next steps in here. Hold on, let me clear a path here. There we go. So next step, I want to know how we go, get my pen back. How do we go to this step? Step number 3. I think that is going to be combining fractions. And this list, just a heads up, this list will not be the same for every single one of these prompts. The list is going to change. You'll have different options to choose from. So try to ignore that for this point. On the third step right here, I think I got there from the second step by, that looks like combining like terms. Right? If you think about what happened, I added secant plus 1 and secant minus 1 together, and that gave me 2 secant plus 1 minus 1. The plus 1 minus 1 cancels out. So it's just 2 secant over secant squared minus 1. And then the question is, we'll use purple for this one. How did I go to that step? Well, there's a tan secretary that can help us out with this one. If you remember this equation, it's 1 plus tangent squared of theta equals secant squared of theta. And look what we have here, secant squared minus 1. Okay, right here. That's what I'm looking at. So secant squared minus 1, that's just equal to tangent squared. Okay, secant squared theta minus 1. So what would I call that? Well, probably, not exactly sure, but I'm guessing we should call that a Pythagorean substitution. Double check the list, see if that's substitute. I don't know how to spell. It's probably an S in there. Okay, it's probably a Pythagorean substitution. Now, next step. Let's move on. How do we go here? Well, what I'm doing now is I'm using a quotient identity to replace tangent with sine over cosine. You see, that's going to make this fraction really big. That's not great, but we do need sines and cosines to solve the problem. What's next? Let's do green. Next step. How do I get to this step? Looks like I'm replacing secant with 1 over cosine. That is a reciprocal identity. And now this fraction is completely intolerable at this point. It's double-decker bus going on here, so I want to simplify that. And the rationale to go from that step to this one would be to simplify the compound fraction, or something similar to that phrase. Okay, whether you do that by keep, flip, change, or by clearing the denominators, multiplying by a crazy one, there's a few different methods, but we're clearing the compound fraction, we're simplifying the compound fraction. And then at this next step, let's see, what do we have here? I use light green. This next one, it looks like I'm pulling out a factor of cotangent right there. Well, what is cotangent? That's just cosine over sine. Okay, and I pulled out a factor of cosine over sine using a quotient identity. And in the very last step, I took a look at that 1 over sine that's left over there, and I'm going to pull out 1 over sine and call that cosecant according to a reciprocal identity. So that's the rationale for each one of these steps, and that's what I want you to go through and do as you work through these example problems. They won't all be like this one. In fact, most of them will not, but the idea is the same.